Hello everyone, thanks for checking out my video today on the different forms of quadratic functions. All right, we want to be able to convert these quadratic functions into any of the three forms and also be able to find a lot of vital information about the parabolas that we'd be graphing from either of the three forms. Okay, so let's start with the three forms and what their pros and cons are. The first form is something we've been looking at a lot so far this year, and it's called standard form. It's the most basic of the three forms. It's also the expanded form of the other two. Okay, the pro of this one is that we can very easily find the y-intercept. All right, why can we really easily find the y-intercept in that? Well, if you put 0 in for x, we are left with just c. So y-intercept would be 0, c. All right, the cons is that it's not as easy to find the vertex, and sometimes can be pretty tricky to find the x-intercepts, if there are any, as well. Vertex form, well, it's called vertex form, so it must be easy to find the vertex, and it is. So the cons then would be that it can be a little bit tricky to find the y-intercept, and possibly also find the x-intercepts if they exist. Intercept form. Well, it's called that. It must be easy to find the x-intercepts. And it is. Okay, our x-intercepts would be r1, 0 and r2, 0 from that function above there. So then the cons would be it could be tricky to find the vertex, and it could be a little bit more difficult than the other ones and find the y-intercept. Okay, so depending on which form you have, finding one of these three things would be easier than finding it in the other forms. So let's just jump right into a very elongated problem about everything that we would need to know for a quadratic function. As we can see, it is currently in standard form, which means it's really easy to find the y-intercept. Right, to find the y-intercept, we just do f of 0, and that would be -3. So our y-intercept is 0, -3. That's the only piece of information that's actually easy to find here. Okay, in intercept form, we're going to need to factor this or use the quadratic formula. Now, luckily, this factors nicely. In fact, that is our intercept form. So our two x-intercepts are 3, 0 and -1, 0. Vertex form. So this one's a little bit trickier. What we got to do for this one is we need to complete the square. So I'm going to rewrite this as f of x equals, group the first two terms together, -3. And then we're going to complete the square on this. So remember, it's the opposite. It's the b over 2 squared. So -2 over 2 is 1. Square that, we get 1. All right, and then we're going to add that inside the parentheses, but also subtract it outside the parentheses. Why? Because we don't want to change the problem. If we add it and subtract it, that means we didn't change the problem. All we did was add 0. And now if we simplify this or factor this, we get x minus 1 squared minus 4. Now it's in vertex form, and the vertex is right here, the opposite of this number, comma this number, 1, -4. All right, the axis of symmetry is the x equals that number of the vertex, so x equals 1. And for the last two, we're going to wait until we graph that to see the increasing and decreasing intervals. All right, let's plot everything that we know. Start with the vertex, 1, -4. And any intercepts that we know, 0, -3, 3, 0, and -1, 0. That really should be enough. The axis of symmetry is x equals 1. We're going to draw that dashed, though, because that's not actually part of our graph. So x equals 1 is a vertical line like that. And it's called the axis of symmetry, means it's symmetric. So this point 2, -3 must also be on there. We have enough information now to graph our parabola. And there we have it. So it is increasing from -1 to infinity and decreasing from -infinity to -1. All right, that sums up a lot of things that we're going to talk about here with quadratics. All right, this slide here, I would suggest you should know how to do these 3 problems from back in our transformation chapter. So I would suggest you pause this video right now, take a few minutes to graph these 3. If you need to graph the parent function and write the rule out, that would be fine. But take a few minutes, graph these 3, and come back and check them when you're done. All right, so for each one here, this would be our parent function. So I'm just going to make that dashed and copy that over. There's your parent function for each one. All right, now if you're writing the rule out for these, this first one would be xy goes to x2y. So we're just going to multiply the y's by 2. And it's become a much skinnier graph here. It's a vertical stretch. Okay, the second one, 2 things happen to it. The y gets flipped and we add 1. So xy, we're going to do the opposite of that, but then add 1 to it. So it's going to look something like that. And the last one, we're going to move left 2 and down 3. So left 2 and down 3, our graph should look like that. Okay, so these 3 say to write the quadratic function in vertex form, identify the vertex and the x and y intercepts. All right, so we're going to do some completing the square for these 3. Start by grouping these together, okay? And then we're going to add b over 2 squared, so 4 over 2 squared is 4, but also subtract b over 2 squared, so these cancel out, okay? And then if we factor and simplify, we get this. So our vertex is then -2, -1. And we also define the x and y intercepts, right? X and y intercepts, yep. So for the y-intercept, that's easy for this form. We just put 0 in for x, and we get 3 back, so 0, 3. And for the x-intercepts, we should try to factor that, if we can. And it does nicely. So our x-intercepts are at -3, 0, -1, 0. All right, so our vertex, our y-intercepts, and our x-intercepts. Number 2, g of x. Let's start with our y-intercept here. So g of 0 would be -4. So our y-intercept is 0, -4. Okay, and then our x-intercepts next. Let's do that next here. So I'm going to pull that negative out first. And see if we can factor that, which we cannot. So that's not going to factor nicely, which means we have to either complete the square or use quadratic formula. So I'm going to use quadratic formula. Opposite of b plus or minus square root of b squared minus 4 times -1 times -4, so that would be plus 16 over 2 times -1, so -2. So it's -6 plus or minus root 52 over -2. So -6 plus or minus 2 root 13 over -2. which is 3 plus or minus 1 root 13. So our x-intercepts are 3 plus or minus root 13, comma 0. Okay, now finally, for finding the vertex and vertex form here, I am going to take that negative out again, of just the first two terms, though. I'm going to group those first two terms together. All right, so b over 2 squared, negative 3 squared is 9. So here's the tricky part, though. We just added 9 here, but we didn't really add 9. We actually subtracted 9, which means to cancel that out, we're going to add 9 out here. So now, if I factor this, I got negative x minus 3 squared plus 5. So our vertex, I'm running out of room here, would be at 3, 5. Okay, last one. Again, let's start with the y-intercept because that's the easiest one. So y-intercept, f of 0 would be 7, so 0, comma 7. All right, so for our x-intercepts, let's see if we can factor this. We probably won't be able to, but let's give it a shot. 2x and x, and then if we try 7 and 1, or 1 and 7, neither one of those are going to work. So let's try using quadratic formula again, or you can try completing the square, whatever you want. Opposite of b plus or minus the square root of b squared minus 4 times 2 times 7, so minus 56, all over 2a. So negative 8 plus or minus root 8 over 4, negative 8 plus or minus 2 root 2 over 4, negative 2 plus or minus root 2 over 2 would be a simplified version of that. So our x-intercepts are negative 2 plus or minus root 2 over 2, comma 0. Which brings us to our vertex form. Okay, so for our vertex form, okay, I'm going to factor out a 2 from just the first two terms here. b over 2 squared, so 4 over 2 squared is 4. So I'm going to add 4 here. But what did I really add? I didn't add 4, I added 8. So now I have to subtract 8 out here to cancel that out. So now I'm left with 2 times x plus 2 squared minus 1. So my vertex is at negative 2, negative 1. Okay, for these last two problems, we're going to need our calculators. So if you need to pause this video to get your calculator out, your graphing calculator out, please do so. Here's my calculator. So let's go ahead into y equals and clear out everything that you see there. Make sure it's all cleared out. Also make sure your plots are turned off. Okay. And let's read through number 4. Jackie Joyner-Kersee won the women's heptathlon during the 1992 Olympics in Barcelona, Spain. Her throw in the shot put can be modeled by h of x, where x is the shot put's horizontal distance traveled in feet, and h of x is the corresponding height in feet. Find the height of the shot put at its highest point and determine how far the shot put traveled when it first hit the ground. So let's first take this equation right here and place that in the y1. So we're in y1 here, negative 0.021 x squared plus x plus 5.5. All right, before we go to the window, we can think about this here. Obviously, we're not going to want negative distance and negative height. So we could start the x and the y at 0, or if you wanted to, you can go a little bit less than that. It doesn't really matter. Okay, so maybe we'll go -1 or -2. And then for the distance traveled and the height, we don't really know how far we can go, but we could play around with those numbers. So let's go to the window. So I'm going to go -1 or -2, whatever. And we can try 20 to see, and then we can always fix that if needed. And then we're going to go -1. I doubt the height is 3,000, so maybe the height would be 10. So we can try 10. And make sure your scales are probably both set at 1. And let's graph that and see what we got. All right, so clearly that is not a good enough graph, okay? So we're going to go back and change our window. We're going to have to make our windows bigger on both X and Y. So let's try that again. Maybe our Y max will be, let's try 25. And our X max, let's try, 50. Graph that. We're close now. That's a pretty decent graph, but we can see that we're not fully seeing the edge of this graph yet. So we got to go a little bit further. Let's go X max is 60. There we go. Now we can see the edge of that graph. All right, so we're trying to find the height, the highest height, and we're trying to find how far it traveled when it hit the ground. So the highest height is another way of asking you, what is the y coordinate of the vertex? Okay? The calculator can do that for you. Hit second, and then hit the trace button, and you see this menu here. We want to do number 4, maximum. And then you want to take your cursor, and you want to scroll just to the left of that vertex, and hit enter. And then scroll just to the right of that vertex, and hit enter. And then you might have to scroll a third time right on top of it, and hit enter. But this one just gives me my answer right away. And the maximum height is the y coordinate. Okay, the y coordinate of the vertex. So you see there it's 17.40476. We always run around to the nearest thousandth. So 17.405 feet. Now it says how far the shot put hit when it hit the ground. So we're trying to see where that shot put, where that graph hits the x-axis. The calculator can do that for you as well. Go second calculate, second trace. And we want number 2, which is 0. And scroll just to the left of where your graph hits the x-axis. Hit enter. And now scroll just to the right of where it hits the x-axis. And again, you might have to hit it a third time, okay, but this calculator just gives me my answer. My answer is, for the distance here, 52.598 feet. Okay? So number 5 is another calculator problem. I would suggest at this point you pause this video to try that problem on your own. Okay, when you finished it, you can come back and I'll walk through answering question 5. All right, if you haven't finished this problem, again, pause and do it on your own, but if you're ready, you can follow along with me here. So I already have the function put into my y1. Okay, I played around with the window a little bit myself here, and this is the best looking window I could come up with, but it doesn't need to be exactly like that. As long as you have a good look at the graph, you're fine. Here's what the graph looks like. Okay, so we're trying to find what is the maximum distance the water will travel. Again, we were trying to find when will the water hit the ground. In other words, when will our graph cross 0? So second calculate, number 2 is 0. Scroll until you are just to the left of that 0, which for some reason my x's are in the 1000s here, so it's going to take me a while to get back here. So bear with me. All right, I don't know if I can wait this long. Let me see if I can figure out a different way to do this here because this is taking forever. There we go. Okay, so now scroll just to the left of that 0. and hit enter. Then scroll just to the right of that 0 and hit enter again. And you'll have to hit enter again one more time, like I said. But here's your answer of 211.397 feet. Okay? So that'll do it for our lesson today on our introduction to the three forms of quadratics and a little bit of calculator skills as well. I hope you enjoyed your video. Come back anytime, and we'll see you again soon.